Hi, we're going to keep talking about imaginary numbers, but now we're going to talk about them in terms of a complex number. How do I identify the parts of a complex number? That will be one of our objectives. The other will be how do I add and subtract complex numbers. So the definition of a complex number, so far, our lesson yesterday, we talked strictly about imaginary numbers, where I comes from. Today we're going to talk about a complex number that we call a plus bi, and it consists of a real part, which is a constant, and an imaginary part, which is a real number times I. So in standard form, the real part comes first. That's what we call a. It's the real part. And then the second part is the plus bi. That's the imaginary part. Even though b is a real number, because it's multiplied by I, it's part of the imaginary component. So these complex numbers look something like 3 plus 2i. It can even look like negative 3 plus 2i, or 14 minus 3i. All right? The constant is the real part. So negative 3 and negative 14, those are reals. And then the part with the I, that's the imaginary part. So 2i and negative 3i. The cool thing about I is that even though it's a number, it behaves like a variable. So it behaves like an x. You can add them together, you can subtract them, and you can multiply them. Let's first start by just practicing identifying the real and the imaginary parts. So what I'm going to do is I'm going to circle the real part. So 7 is my real component, and I'm going to underline my imaginary. 3i is my imaginary. For example B, 2 is my real, and negative 4i is my imaginary. Getting it? C's a little bit different because it only has, what we can see is negative 5 is the real part. But what we know is that it had to have had 0i as the imaginary. All right? And D, well, that looks just like an imaginary, but what it has to have is a 0 real part. It has a 0 real part and a negative 6 imaginary. So all along when we've been working in the real number field, we've also been working in the complex number field, because every real number is also a complex number that has a coefficient b equaling 0. So every real number would be like negative 5 plus 0i, or 4/3 plus 0i. We just don't write 0i, okay? Every imaginary is also a complex with the constant component being 0. So negative 6i is 0 minus 6i. This is the real part, okay? We just don't write it when it's 0. So now let's move into adding these complex numbers together and then subtracting the complex numbers. So when you add complex numbers, you take their constants or their real parts and you add those together or combine them. And then you take the imaginary components of both numbers, or however many numbers you're adding, and you combine those. So in this case, I'm adding the complex number 7 plus 3i with 16 plus 6i. So I take the 7 and the 16 and I add those together, and that gives me 23. Then I take the imaginary part, 3i plus 6i, and I add those together, and notice that if I have 3 i's over on my left hand and 6 i's over in my right hand, then I add them together and I have 9 of those i's. Right? So I just add them just like I would if it was like 3x plus 6x, and that's going to give me 9i. Now when you go to subtract them, the only step you have to include is to distribute the negative sign before you actually do your combining of your constants and your imaginaries. So I took the same two complex numbers, 7 plus 3i, 16 plus 6i, and now I'm subtracting them. All right? So I don't have anything to change in my first complex number, so I just rewrote it. But now what I'm going to do is I'm going to distribute that negative across my complex number. So I get minus, hold on, so I get minus 16 and then minus 6i. Now I take my constants, or my real parts, and I add them together. 7 plus negative 16 is negative 9. Now I move to my imaginary parts. Positive 3i minus 6i is going to give me negative 3i. So think combine like terms. So let's do some practicing. All right, this first one, we're adding these two complex numbers together. So I'm going to add my real components, what I also refer to as the constants. So I'm going to go 2 plus 6, and that's going to give me 8. And then I'm going to go 3i plus 4i, and that's going to give me plus 7i. Now you go ahead and add the two complex numbers in example B. All right, so I'm going to go negative 11 plus 13. Negative 11 plus 13, that's 2. And then I'm going to go 6i plus negative 2i. So I'm going to get 2 plus 4i. All right, now I'm going to demonstrate a subtraction. I'm going to distribute this negative sign first. So I'm going to rewrite my first complex number, and then I'm going to distribute the negative. So I get minus 3 plus I. Now I'm going to combine my constants. 4 plus a negative 3, that's 1. 2i plus one more I, that's positive 3i. Right? So you do example D and come back and see if you got it right. So I'm going to do 6 minus 3. Well, I'm going to do 6 plus 5i minus 3 minus 2i. So I get 6 minus 3, that equals 3. And then 5i minus 2i is 3i, just like that. Now, we can add more than two complex numbers together, and all we do is follow the same pattern. Combine your constants and then combine your imaginaries. So 7 plus 8 is 15 plus 2, that gives me 17. Negative 3i minus 6i, that's negative 9i, minus 4i, that's negative 13i. Okay? All right, you guys try F and see if you get it right. I'm going to distribute first. My first term stays as it is. My second term, I distribute. My third term, I distribute. Negative 9 minus 9 is negative 18, plus 15 is negative 3. And then 4i minus 8i is negative 4i, minus 2 is negative 6i. Okay, all right. We're going to go ahead and watch the multiplying video, and I'll see you tomorrow.